Hi, my name is Josh Stella, and I'm going to be talking to you today about serverless security, and particularly how folks can leverage it, hackers that is, to steal your data and get into your accounts, and how you can prevent them. Uh, a lot of this is going to be focused on IAM and AWS, but the concepts are similar across the different cloud providers. I am the co-founder and CEO slash CTO of Fugue. Fugue is a cloud security software company, SaaS company. And this is really all I've done for about a decade. Prior to founding Fugue, I was a principal SA at AWS, focused on national security kinds of environments, Department of Defense, and so on. So I've spent about the last 10 years working on this stuff, and hopefully that gives me a few things to tell you about that will make you think. All right, what we're going to do today, we've only got a half hour, so we're going to go pretty quick. I'm going to set the table on serverless security and IAM. I'm going to do a deep dive into IAM and other kinds of misconfigurations in serverless cloud environments, because they are fundamentally different than data center kinds of environments or virtual machine oriented kinds of environments. I'm going to give you some recommendations, and we'll have some Q&A. All right, let's just dive in. So why do we need to rethink security in a serverless world? It's for a number of reasons. The principal one is that serverless applications are fundamentally distributed applications. A lot of what would be handled kind of in memory, one function talking to another on the same server in a serverless application is a network call, is going across a network boundary. Very often those network boundaries are kind of invisible. And so IAM, Identity and Access Management on AWS, and similar kinds of services on Azure and Google really define that network. Okay, and this is a new way to think about IAM. IAM is the fundamental network in serverless applications, and we'll come back to that quite a bit. All right, and many of those potential misconfigurations involving IAM in serverless are not seen as problems by compliance frameworks like NIST 800-53 or SOC 2 or CIS. Those grew out of a more traditional software architecture running on more traditional servers, and they think of the world that way. Serverless is very, very different, and so they're not always going to be super helpful to you. Therefore, a lot of these potential misconfigurations, these dangerous configurations, exploitable configurations, are not seen as vulnerabilities by your security teams. So you might be passing audits and the security team's happy and still have these vulnerabilities in your environment. Also, things only become apparent, a lot of these misconfigurations, in the full context of the environment. If you're talking about a Lambda function, you can think about the security of the particular Lambda function on its own, and that's fine. But much more important is where it sits and what it's talking to and what's around it and what are those connections. All right. This combination makes these things really common in serverless environments. It's really common for people to make security mistakes when designing a serverless architecture. And that means a lot of applications built this way are exploitable. And in the cloud, very often, when you are exploited, when you are hacked, you don't know about it, even afterwards, unless the hacker, asks you for money or, brags on the internet or something like this. So it's a real problem. It's a complex problem. All right, I want to talk about the shared responsibility model in cloud, because this is where serverless is really your friend. Okay. So what the shared responsibility model is, and this presentation is talking about AWS specifically. Of course, Fugue, our product, works on all three of the big cloud providers, but I had to pick one. to deep dive on. So we're doing AWS, and that's where I came from. So the shared responsibility model really says for security of your applications, there's the stuff AWS is responsible for, or Microsoft or Google, and there's the stuff you're responsible for. And so on this diagram from AWS, you can see the orange stuff is what they're taking responsibility for. So that's things down at the bottom, like actual physical locations. Can somebody walk into a data center, who doesn't have authorization and things like that? And that's expressed in regions and AZs and edge locations. And then there's the network that connects the cloud together, the AWS cloud together. And then there are the services themselves, but not the configuration of the services, the maintenance of the services, the compute, storage, database, networking services. And of course, there's also software that they offer, higher order software. So that's what AWS are saying that they are responsible for. Everything else is you. And that means all of your data encryption, all of your network layer, all of your identity and access management, your operating systems, your firewall configurations, all the customer data, that's all on you. Okay, so the reason I'm showing this in a serverless context is Fugue, in our early version of our product, we were building on top of virtual machines. We were building on top of EC2 instances, and later we re-architected to be pretty much 100% serverless, function as a service, using Lambda and some containers, but we try to stick with Lambda where we can. And the beauty of this is there's so much of the attack surface that we have shifted to AWS by doing this. So we don't run any operating systems. It was really interesting. We were getting a SOC 2 audit, and they said, how do you patch your operating systems in your production environment? We said, well, we don't manage any operating systems in our production environment. And that's a beautiful thing. AWS and Microsoft, et cetera, the CSPs are really good at that stuff, and they do this all day for a living. And there is no business benefit to me, to Fugue, for maintaining operating systems. It doesn't do anything for us. It's just overhead, and risk. So when you're doing serverless, you are shifting a lot of the responsibility back onto the cloud service provider, and that is a really good thing. However, you have to understand that when you do that, and you're going to the distributed architecture that I was talking about before in serverless, where you're going to have a lot more connections between things and a lot more objects connected, you have to understand the cost of that, which is that you really need to take ownership of how you are securing those interactions in that distributed system. And that's what we're going to focus on today. All right. That's all my slides. I think I have a couple at the end just with some suggestions and so on, but I'm not a big fan of slides. I'm going to whiteboard today mostly. All right. So some core concepts around cloud security. So one core concept in cloud security is how you describe policies that allow things to talk to each other. So again, using AWS today, when we're doing these kinds of policies, there are a few primary kinds of things. So we have principals. A principal is like a user. Maybe this one's me. But it can also be I'll just put a Lambda in here and call it foo. A principal can also be a piece of your architecture, a piece of your application. And this is, in fact, how you do security and connections in these serverless architectures, okay? So principals are actors. Principals are, if you ever did UML, you would have actors, right? They're things that set other events in motion, all right? So we've got principals, and then we have actions. And that's stuff like, get object, from an S3 bucket. There are thousands and thousands of these actions in any of these clouds. You know, EC2 alone has over 400 different actions that are in that service. And what you're going to find is that pretty much the entire capability of the cloud, with very, very few exceptions, things you have to pick up a phone for, are going to be done through these actions. It's just a big, long list of verbs. All right. And then we have resources. Boy, I'm not drawing too well today. So resources are things like, let's have an S3 bucket, we'll call it bar. And, you know, you might have a container, you might have other Lambdas, you might have an RDS database, but resources are the instances of cloud services. They're the actual things, the things that have, you know, IDs associated with them. All right, so there is a default policy in AWS for all of these interactions, which is deny. Okay, so if a principal, like let's say Josh over here, I want to get an object from S3. So I want to be able to call get object on this S3 bucket. Well, out of the box, I'm going to get denied because, first of all, I don't have allowance to use the get object action. And then I also don't have allowance to talk to the S3 bucket called bar. So policies are how we open these connections up in the cloud between different things. Okay. And they can be extremely limited. You might have a policy, and in this case expressed as IAM, that only allows me to see one S3 bucket and, you know, really, really restricts me. Where we get in trouble is when those policies are overly general or kind of overly liberal, too permissive. We open up too much stuff. It's very common, for example, in IAM policies, which is largely what we're going to be talking about today. There are other kinds to use like resource star, like any S3. And that can make sense, but in serverless, it really doesn't. And we'll get into why. Okay, but the idea here is the way you can connect things in a functional graph, you know, data flow or whatever, is through these allowances to talk to each other, to perform specific actions on specific resources. All right, that's just the way this stuff is done. And if you think about that, well, let's graph that out. Let's diagram that and talk about what the implications are. Because typically in a serverless application, you're gonna have a lot of functions. Okay, quite a lot. Let's talk about just you know, a good starting architecture. You want some kind of a gateway. Maybe you start with, you know, the API gateway, right? And then you'll probably have a number of kind of handler Lambdas for the different kinds of requests that come in through your application through that gateway. So that's a very typical pattern, depending on, you know, what the request is coming through the gateway. It gets routed to the appropriate initial function, which then sets off a chain of events. And very typically what you'll have in serverless functions are kind of way back here somewhere. You'll have, excuse me, things like your database, right? Or you might have S3. You're going to have persistence, data persistence somewhere. And then you're going to have a chain of functions. Typically, sometimes they're going to persistent storage and then that fires another function, and sometimes it's direct, but you're probably going to have a lot of these guys sitting out here that get chained together in different ways. All right. And some of them, and because each function, I mean, a well-designed serverless application, in my opinion, should have idempotency at a function level. It should, generally speaking, except for things that are going to persistent storage, which should be few, you should limit where you do that, because it creates vulnerability, and it also creates complexity and dependency just architecturally. You're going to have these things talking to each other. So if I come in and say, okay, I'm just going to use a blue pen here. As some user, some guy out on the internet, or lady out on the internet, asks my app to do something, therefore hits the API gateway. Maybe it's with an API call, maybe it's a web browser invocation, whatever it is, they hit the front of it. And that's going to get routed to one of these Lambdas. Now, let's say that this particular function requires a path through these Lambdas that looks like this. Okay, so step one was API gateway to initial Lambda. Step two is initial Lambda fires, maybe it fires a couple of Lambdas. But let's just focus on this kind of southern route I've drawn here. Lambda A, I'll just name it here. Let's call this A and B. Lambda A invokes Lambda B, and Lambda B drops something in S3. And when that gets dropped in S3, Lambda C is looking at that S3 bucket, performs some function, writes something to a database, and then somewhere along the line here, maybe it also talks to this guy, and that goes back and returns back out to the user, right? So what we're doing here is we're tracing the flow of invocations and actions that these serverless objects need to have in order to perform their function. So this is going to be done through their IAM role. And let me switch to a web browser and just show you that briefly. I'm going to show you an EC2 instance, but it works the same way. So this is our product Fugue. We do these diagrams for you. This is not a pitch session, but it's really handy because Fugue will let you explore all the details of your configuration and find security flaws. So here I've selected an EC2 instance, and you can see right here, it has an IAM instance profile and an IAM role. Now, what those are the permissions, the allowances, right? The holes through the deny walls that compute infrastructure has. We've assigned it to it. And so this is a really, really powerful idea, because as you're constructing, your application, you don't really have to worry about network. You don't have to worry about what subnet something is in, or having ACLs or any of that stuff. And security groups become much less important in these serverless applications for the most part than they are in other kinds, because you're really defining the ability for these things to talk to each other through their IAM roles. So I teach a lot of classes on security in the cloud. You can check out our YouTube channel. There's a bunch up there. But this one is focused on serverless. In the other ones, I will often say, try not to proliferate IAM roles. Try not to make too many of them, because if you do, you're going to have to manage them. And that becomes its own burden. Well, if you're doing serverless, that's a burden you're going to have to take on, is my opinion. So what your goal here is, as you're defining these policies, and I'm going to use, what should I use? I'll use a green marker. You want only the actual transactions, only the actions to only the resources that Lambda needs, that function needs. You don't want any other. So you don't want you could, for example, have a Lambda A could have the ability to do an execute on Lambda B, or an execute on all Lambdas. All Lambdas is bad. Don't do that. You want it only on B. Well, when you start thinking, or whatever the collection of Lambdas it needs to execute, because execute allowance, right, permission to execute, is dangerous. It's dangerous if a hacker gets a hold of it. Oh, I should talk about what hackers are going to try to do. So what hackers are always trying to do in the cloud, and even when they break into servers, compute instances or containers, typically what they don't really care about that. It's a means to an end. What they're trying to get are API keys. Almost always, they are trying to get API keys that provide those permissions and allowances I was talking about. Okay, so when that Lambda is invoked, it invokes with a set of permissions, and if you can get a hold of its permissions, then you can use them to your own end and do exploration. For example, 90% of hacking is discovery. It may be 95, maybe 99. Mostly it's learning about the environment. So if a hacker manages to get a hold of API keys that are being used in your application, you don't want them to be able to do much with them. You want a very limited blast radius. So you'll read a lot about in the news. I think it was the several of the Uber breaches where there were admin level API keys in a GitHub repo that a hacker got to that were long lived. That's really bad. Don't ever do that. Don't ever have long lived administrative API keys unless it's a total junk environment like a sandbox or something. So what in serverless, what you're wanting to do is have the most limited allowances you can, the least permissive, right? The least privilege in the system, but you're doing this on this big distributed graph, and that gets really complex. So one recommendation that I think the only kind of sane way to handle this is to make automation of building those policies part of your application development. So every time you deploy a version of the app, we have hundreds of Lambdas. At Fugue, we do, billions of processes with those. We manage millions of cloud security resources for cloud security for our customers. And when we deploy a new Lambda or modify an existing one, part of the job is to make sure it is least privileged and that its permissions are automatically built as part of it being built. It's just another part of writing that piece of the app. And I think that's the only really kind of sane way to deal with what is a pretty complex scenario. So if you automate these things, you're going to end up with a lot of IAM roles and a lot of policies, and that's okay in serverless. So we're getting close to the end of our time, and I do want to talk about some things other than just how to construct your IAM. In a half an hour, I have to cover this at a pretty high level, but again, on our YouTube channel, we've got deeper content on this stuff as well. All right, so that's our deep dive for today, but I want to get to some of these recommendations. All right, so right at the top, least privilege, one IAM role per function. Other things to focus on: be really careful about cross-account IAM. That can expose you in ways that are hard to even be aware of or see, and it's quite dangerous. So if you're doing any cross-account IAM stuff, you're going to need to be especially careful and keep track of exactly what's doing what, and have a lot of governance there. And these are the kinds of things that our product and others can help you with too. Yeah, we didn't really talk about code injection. In one form of this this talk, we actually go into source code for a Lambda and show you where you can make errors. But in the world of serverless, you don't have an operating system to hack into. So the hacker is very often, they're either attacking straight against the API, CSP API, or they're trying to hack into the function itself and get the permissions and go from there. So you still have to write secure code. You have to write secure application code. So a good idea to do code reviews, and in particular, look out for event injection types of potential breaches. All right, delete Lambdas you are no longer using. Delete everything you're no longer using. Stuff you've forgotten about, orphaned infrastructure often is a really wonderful attack surface for hackers because you're probably not maintaining it. And if it's still sitting out there, even if you're not really using it, it probably still has permissions to do stuff. So that's a really bad combination. So get rid of stuff you're not using. All right, within the actual serverless functions themselves, you want to minimize the dependencies and you want to keep them up to date so that you're avoiding vulnerabilities in your libraries, right? And there are products out there, Cenotype and others that can help with that. Okay, yeah, this next one's an interesting one. Don't use the Lambda execution environment to store user data or events. This avoids potential for data leaking across invocations. So this is something a lot of folks don't think about, but if you are storing any data in that Lambda, the next time that Lambda gets invoked, that data might still be around. And very often in these architectures, that is not going to be for the same user, right? So user A comes in and invokes that Lambda to log in or whatever. And then the next time that Lambda gets invoked, it's a different user, but there may be data cached sitting in that execution environment from user A's login when user B gets there. And if user B is a hacker and is exploiting that Lambda in order to do things like, extract information from it, they might get user data there. They might get dangerous data there. So be aware of that anything that you are bringing into the execution environment, memory-wise, data-wise, is potentially a cross invocation data leak. All right. Yeah, avoid executing shell scripts within Lambdas if possible. This says, especially if handling user input, I would say just avoid it. It opens up a whole other realm of potential error. Yeah, Lambdas shouldn't be sitting there on with a public IP address in front of, just exposed to the world. You should be putting them behind something like the API gateway and using the appropriate authentication mechanisms in API gateway, which are really good. All right, and yeah, protect your APIs with a WAF, including APIs in front of Lambda functions. So you still have to be worried about that application security. All right, so some key takeaways. Serverless security is deeply architectural. It has to be built into your architecture when you're doing serverless, because your architecture is no longer function calling function in memory. It's function calling function over a distributed network. And but you still do need to write secure code. So each Lambda needs to be secure, and the way you string them together needs to be secure. Yeah, new serverless code can still contain the old well-known vulnerabilities, of course. If you're using a library that has a CVE on it, you're still using a library that can be exploited. So we've talked about this a lot. IAM is your primary vulnerability surface, not the only one. Lambdas can be reused across multiple requests, and data remains available for future invocations. This is an interesting one that I didn't talk about. Usually people think about putting things in VPCs as a security benefit. In the case of Lambdas, arguably it's the opposite. That when you put them in VPCs, what you're actually doing is allowing other ways to get to them through policy. So VPCs can provide an attacker with a path they wouldn't have, and they don't necessarily add to your security posture. You have to look at your specific app to do your own analysis of this, but I think usually it's worse, not better, from a security perspective to use VPCs. All right, define core secure configurations and use those in a base template for Lambda instances in terms of limiting your dependencies and so on. You don't want a proliferation of code libraries and dependencies across your fleet. You really want to manage those. Yeah, use a tool that can evaluate your cloud configurations for security and compliance. We can help you with that. There are other vendors. Oh, right. EC2 resources that are sitting in your environment can be a really nice attack vector for going after your serverless. So be very aware of that. And you know, compliance rules aren't gonna help you much here. You really have to be thinking in a serverless way, and you want to think about, you know, least privilege, etc. Okay, so here is my contact info. I'm around for some Q&A, and it's been fun talking to you. You can reach me at josh@fugue.co, not .com, but co. And thanks much for attending the session. I hope you enjoyed it.